Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thanks so much for joining me on another video where we're going to continue learning about the Rust programming language. If you're following along with the Rust programming playlist, which I'll have linked in the description and the pinned comment down below, you'll probably know that the last video covered some fundamental data types in Rust, such as integers and string pointers, Boolean values, floating point values, and things of that nature that we can use to build more complex types. Now, we're going to talk about more complex types in a future video, but for now, one of the other fundamental concepts in the Rust programming language that I wanted to discuss are functions, how we define functions, how we declare input and output parameters, and also how we can organize our code by using Rust modules. As you may have seen in the data types video, we built out a simple function here called testfunc, but it didn't take any input parameters or return any values back from this function. And instead, we just put a ton of different code inside of this function, and it got really, really long, right? So instead of building out really long source code files, we can use modules inside of Rust to kind of segment our code and to logically organize it into these separate modules so that we can simplify the APIs for our application. So what we're going to do for starters is to just comment out this test function here. I'm going to leave that file in here or this function in here, but I'm just going to comment it out so that my Rust program doesn't continue to call all of the code in that test function for the data types. Instead, what I'm going to do is start off by declaring a simple function, and then we are going to put that into a separate module inside of our project. And this will allow us to use multiple source code files for our project rather than sticking everything inside of main.rs here. So let's go ahead and define a function here, and we'll call it, how about get full name, okay? And what we're going to do inside of this function is we're going to accept a person's first name and a last name as input arguments to the function. And then we're going to return the person's full name separated by a space. So inside of the parentheses after the function, this is where we can declare our function input parameters or input arguments, depending on what you want to call them. So what we're going to do for starters is say we have a argument here called first, and this is going to be of type string pointer. We're going to take in a last, and that also is going to be a string pointer. So those are the two input arguments that we want for this function, but we also want the function to return a value after we've combined that first and last name into a full name, right? And so the data type that we're going to return in this case is going to be a string, which is a built-in data type in Rust that allows us to basically return a value that's stored on the Rust heap. So what we're going to do is, first of all, need to combine inside the body of this function the person's first and last name. Of course, we'll put a space in the middle as well. So we need to declare a new variable containing a string data type, and then we can return that variable back from this function to the caller, right? So what we're going to do is say let result, or actually let's do let full underscore name just to be a little bit more explicit. And then what kind of expression can we use that actually joins first and last together? Well, what we can do is use a macro called the format macro. And the format macro allows us to pass in a format string, very similar to the print line macro that we've been using. And we can actually pass in some arguments to that input format string, and that will construct a capital string object here that we can then return back to the function's caller. So what we'll do is call this macro right here, and we'll just put in a couple of placeholders, and I'll use index 0 and index 1 to denote which order they're supposed to go in. So we'll do a curly brace index 0, then we'll put a physical space after that, and then we'll do curly braces with index 1 inside of there. And then once we've declared that format string, right, we want first name space last name. That's the basic structure. But to actually pass the values into that format macro, we need to do a comma, and then we'll specify first as well as another comma and last. And then we'll put a semicolon at the end here so the compiler stops complaining. And as you can see, this is how we can construct one of these new string objects here. And even though we didn't specify the type here, you can see that the type was inferred from the result that comes back from this macro right here. You can see in the documentation, it says that it creates a string, right? So now we take these two string pointers as inputs, we combine them into a resulting string, and then finally we need to return the value back to the caller. So if I save my main.rs file right here, you can see that we have mismatched types here, and this error is occurring because we've declared that our function should be returning a string object, but if we look at our function body, we haven't actually returned one anywhere. We've declared a new variable called full name, but we didn't return that value anywhere from our function. So at the end, we'll just say return full name, and that will satisfy that requirement of our function declaration here to return a string value. But now we get this message here that says function is never used. And we get the same thing down here because we commented out our invocation of testfunc down here in our main function. And so we're not using either of these functions right now. Now, I don't want to get too deep into attributes for now, but there is a mechanism for us to leave this code in place, but simply cut out that warning so that Rust stops warning us that our function is unused. It's basically our way of telling the Rust compiler, look, I know I'm fully aware that this function isn't being called, but I just want you to allow it for the time being. So there is a attribute that we can use called the allow attribute. And if we specify that we have dead code in here, we can actually override the compiler's warning that indicates that we have uncalled code. And so I'm going to move that attribute down here under testfunc, or actually right before testfunc. And so this is called an outer attribute in Rust. There's also inner attributes that are used inside of code blocks as well. But the outer attribute basically applies to the item or the function declaration that directly follows that attribute. And the way that we know that this is an outer attribute is because it has a hash sign, not a hash sign followed by an exclamation point, which is also known as a bang character, right? So the outer attributes just have a hashtag here, and then we have our opening and closing square brackets, and then inside there we have the actual declaration of the attribute that we want to use. Now we are going to be using the getFullName function, and so that's why I'm not going to put that allow attribute above this function. So what we're going to do is back inside of our main function, we'll call the getFullName function, and then we'll pass in a couple of names. So let's plug in a first name of Shane and a last name. We'll just do quotes and say Jones. All right. So let's put a semicolon right after that. Now we're successfully calling the function. But what you'll notice is that we are not capturing the return value from the function. So what we need to do is declare a new variable to hold that value. So we'll do let my result equal the result of getFullName. Now we are assigning this variable called myResult, but we're not actually referencing it anywhere. So it's going to give us a warning that says unused variable. And it does infer that the type of this variable is going to be a capital string because on our function definition right here, we've declared that the return type is going to be a string. So the Rust compiler knows what data type is getting returned. And that's why we didn't have to explicitly specify it in our code. This little colon and string is actually just being displayed by the editor. It's not actually part of my code itself. So now let's say we want to use this result somewhere in a sentence. So we'll use the printline macro here and say hello from, and then we'll do a placeholder here and pass in my result. All right, so let's go ahead and save that. And down here in our terminal, we'll do a cargo run. And as you can see, we get hello from Shane Jones right here at the end of our main function. So that's how we can declare a function with input arguments as well as outputs as well. So what we're going to do now is to actually take this function and we're going to refactor it into a separate module so that we're not gumming up our main.rs file with tons of helper functions. We want to take those helper functions, put them into a separate module so that we don't have to see that in our main application code here. So the way that we do this in Rust is to actually create another file, but unfortunately the Rust compiler, if we run rustc down here, you'll actually notice that the Rust compiler only takes a single input here. We can't actually specify multiple RS files as source code inputs to the Rust compiler. I know that some other languages, like I believe the Go compiler actually uses multiple input files, but in the case of Rust, we can't do that. So the way that we accomplish this is to, of course, first create another source code file in our project right here. So right now I only have main.rs, but I'm going to create another file here called helpers.rs. And then I want to move this function called getFullName. I'll just cut that, save main.rs, and then open up helpers, and we'll just paste that function into this helpers file. Now, if we go back to main.rs right here, you're going to see that we get this error that says cannot find function getFullName in this scope. And that's because our main.rs file no longer declares the getFullName function. It's now being declared in our helpers.rs file. So in order for the main RS file to know that there is a separate module file, a separate source code file in our Rust project, we actually have to go into main.rs and declare it as a module. So we'll say pub mod, and then just the name of our source code file, which is helpers, and we'll go ahead and save that. But as you can see, even though we've declared our external file as a module, we are still getting this error that indicates that the function can't be found. And that's because it's still looking in the current scope. So now you might say, okay, well, let's prefix this function call with helpers, right? So we do helpers and then 2 colons and then call getFullName. Well, check it out. It still says that function getFullName is private. And that's because by default, items that are exported from Rust modules have a private accessibility or visibility from them. So that means that our main RS file here doesn't have visibility into private members that have been declared in the separate helpers.rs file. So what we need to do to resolve this is to turn this private function in our helpers module into a public function. And all we have to do is add the pub visibility specifier right before the function declaration. So now if we save helpers.rs and then come right back into our main function, you can see that that error has now gone away because getFullName is now public and visible from other files besides helpers itself, right? So now we can call helpers getFullName. And if we do a cargo run right here, you can see that our program compiles and runs successfully. So that's how we can declare external modules. Of course, if you specify an invalid module name to a source code file that simply doesn't exist inside of your project, then we'll get an error there as well. So if I called this Trevor helpers instead of just helpers, you can see we get this message that says unresolved module, can't find the module file called trevorhelpers.rs. So Rust is a very friendly language and framework. It helps us to identify very specific issues inside of our code. It's telling us right here that it's looking for a file called trevorhelpers.rs, and it simply can't find that. So of course, to resolve that, we would either have to fix the name of the module to point to a module that does exist, or we could go out and implement the module with that new file name. Now you can also create child modules in Rust modules. So at the moment we have a module called helpers, which is just a separate source code file where we've declared a public function. However, helpers as a module can contain its own child modules, so we can further segment our code into additional child modules within a parent module. Now to do that, we can simply create another code block inside of our module and then say pub mod and then give our child module another name. So I'll call this name helpers. And so we say pubmod name helpers. So now name helpers is actually a child module of helpers. And so if I move my function get full name into the scope of this name helpers child module, now it's a member of name helpers, which is part of helpers, rather than just being a direct child of the helpers module. So of course, anytime that you're changing the module path of one of your entities in your Rust project, you need to make sure that you update the references to that particular function or item. So in this case, down here, we can see that we get an error once again saying that we can't find get full name inside of the helpers module. So of course, in order to resolve that, we would need to go into the child module. So we'll do helpers : name helpers : and then finally get full name. And that resolves the error there. And then once again, we should be able to do a cargo run and compile and execute our program successfully here. So that's just a little bit about modules and how private and public visibility work, as well as how we can nest child modules inside of parent modules. So at this point, what we could do is go ahead and continue to define functions directly under helpers. We could define other functions under name-specific helpers here, and we could continue to build out other child modules. So you're not just limited to having one child module. We could declare another module here called, pub mod database or something like that. If we need to do some kind of data access layer type of stuff, we could kind of segment that all into a separate module, and we could create additional helper functions inside of that child module. And then if we come back to our parent module here, if we were trying to call something from helpers, we can now see that we get this auto completion from the VS Code Rust Analyzer extension that is showing us dynamically the modules that are publicly visible from our child module. If we declare a module that's called something like private fns, then we should not be able to see that under our list of child modules. But as soon as we go to that module and turn it into a pub visibility module, we should be able to see that private fn's child module show up in our auto completion here. So we could go ahead and just kind of build out additional functions here. Remember that Rust functions can take various types of input arguments here. They can also return different types of arguments as well. And so if we wanted to, down in this data access layer here, we could just define another function. So we could do maybe pub fn and then say get age. Or actually, let's do get underscore age. That's a little bit more in line with Rust naming conventions. And we'll just do get age plus 5. And then we'll take an input age as an unsigned integer. So let's say age is unsigned about 16-bit integer. And then we'll just return back whatever the new age is. So we'll return back another unsigned integer here. And then what we'll do inside of this function is just say return age plus 5. And so now this age function will just give us whatever our input is, add 5, and then return the result back to the caller. Let's go ahead and try that and see if that function works. So we'll say let new age equal helpers. We'll go down into the private fn's child module. Then we'll call get age plus 5, and we'll pass in an age of, how about 23? Go ahead and put a semicolon on the end there and say the new age is, put in a placeholder there, and then we'll pass in the new age variable. All right. So now that we've got that function defined in there, we'll do a cargo run, and of course 23 plus 5 is going to be 28, and that's the result we get. So anyway, that's just kind of an introductory view to functions and modules inside of Rust. One thing I wanted to point out is that a lot of people online have said that you actually need to use cargo in order to create multi-file Rust projects because the Rust compiler can only take one input file. So in this case, it's going to be main rs. But what's really interesting is that you actually don't have to use cargo. I'm pretty sure that most projects in Rust are going to use cargo just because managing external dependencies for your application is much easier with cargo, and you don't have to worry about copying source code files around and that kind of thing. But you can actually create a Rust project that has multiple source code files and doesn't use cargo at all. And just to prove that to you, I'm going to take the main.rs and helpers file and put them into a separate folder just by themselves without the cargo.toml file, and then we'll try to compile that project and see if it works, okay? So we'll go up here and I'll go into my subfolder here. And I think I have a couple of files in there, so I'll just do rm star, and then I'll just copy both of these files. So we'll say cp // and then we'll go into app and grab main.rs, and we'll also grab helpers.rs, and then we'll just copy those into the current directory, which is just period here. So now if we do ls-lga, we've got main and helpers. So we have no cargo file. If we try to do cargo run, it's going to complain and tell us that it can't find the cargo.toml metadata file. But what we can do is use the Rust compiler directly to compile main.rs. And as you can see, the compiler worked perfectly fine. It didn't throw any errors, even though we don't use cargo, right? So we have a multi-file Rust project, but we're not using cargo. So now we have a third file, which is our binary that was generated by Rust. It's about 4 megabytes in size, even though our program is pretty small. So now if we execute the main binary, you can see that we get the exact same results as we did when we had cargo present. So even though some people may think that you need cargo to do multi-file projects with multiple modules, you don't actually need it. But of course, if you're dealing with external crates and things like that, which most projects probably are going to, then you should use cargo. But I just wanted to make sure that you are aware that it's not totally mandatory. Anyway, that's pretty much everything that I wanted to cover. So feel free to check out the other playlists on my channel. And please like this video if you learned something new, subscribe to the channel, and please leave a comment and let me know what you thought of this video and what other topics you'd like to see on my video channel. Thanks for watching, and we'll see you in the next video. Take care.